Let's start Discrete Mathematics with a propositional logic. Okay, the core concept of proposition logic is we have definition for this. A problem is a statement. A problem is a statement that is either true or false, but not both. So we have a problem. It could be true or false, but it will not both. Examples are here. 2 plus 3 is equal to 5, which is true, and his 9 is a prime number, so false. And if you don't know what is prime number, and here's I have written a number can be divided exactly only by itself or 1. So would be example 7, 17, and so on. So this is divisible, that's why it's false. Close the door, not a proportion. Okay, and this is also a not a proportion. Why? X is greater than 5. X is greater than 5, but it could be proposition. Let me tell you why. Because it depends on x. X could be greater than 5, it could be 6, then it will be true, right? But what if it is not, like it is 2? So it depends on 5 because 2 is not greater than 5. So it's depend what is our x. So we have to define the x first to make it true or false. Here's our logic for that. Logic operators where we use truth table. We will come that on, but let's see what we have in a logic operator. So P a proposition and Q is also a proposition, another proposition. So let's see the symbols. This is not P. This symbol like a pistol, gun pistol. This is a not, and about this is also like name for it, not. What P is exactly means the opposite of P. So if we will see, like if it is true then false, if false then true, so it will be just opposite. What about this? And so the second symbol is and. The symbol I remember is like A, but if you have like middle thing over here, so in and the both condition must be true. So the both true and true will happen, then only it will be true, the result will be true. If one of the condition is false, then it will not satisfied and it will be false. So both P and Q will be true. P or Q. So P or Q at least one true. So either P can be true or Q can be true, but both should not be false, right? Because we need one true. P implies Q. If P, then Q. If P, if our P is true, then like when we say if I want to eat something, then I have to cook. Or if it's raining, then wear a the raincoat, wear a raincoat if it's raining, or if it's raining, have a umbrella, then go outside, right? Like that. And this is if we will see this thing, it's both same. Okay, so it's something good special, we will look afterwards. The truth tables, which is for not, over here, not. So let's see what is the truth table for not. So true, false. Okay, so and we have here not p, which is opposite I have said. So true becomes false in not p. Here is not p. So whatever true we have, it will automatically, when we do not, it become false. And same with happen with the false, it become true. So false become true and true become false in not. Remember this. It's just opposite of what we have about this and. So in here and table we said both must be true in and, right? So and p q p and this angular sign symbol q, which is and, right? So true true become true, true false become false because it have false, and false true become false because it has false. False false become false. I was making it true because like I thought for a moment like true true becomes true, so the false becomes also true, right? But no, here false in and become false because both must be true to give the result true. And this thing how it's come, like I remember this for checking this table, how we remember is truth, false. And here I remember this q as tutti frutti, and this is for checking this result, right? So that's how I remember tutti frutti, and this is just truth, false. So here let's come for the or. This would be same for everyone. So let's check for the or. Truth, false, tutti frutti. And in or, the symbol how I remember is like when we write a small r, we just do this. So like that, but it's a V. So symbol, but I remember it as a R small. So in or, what we have, at least one should be true, right? If I got true from the P or either from the Q, I will write the result true. So let's see, true will, because I got true, I automatically write the result true. Here also I got true, I will true, I will not see false. Okay, so here is a false, but I see here true, so I will write true. And now here false, and now here false, so it will be false because I need to one true to write here true. If both are false, then it will be false because we need one in or. Then this is implication or implies, which is if then q. So pq, this will be the same as over here we done true, false, tutti frutti, true, false. And the thing is here is I want you to just focus on these two because these two confuse me a lot. If you get this, it's okay. If you not get this, then it's also okay because I also not get this completely. But let's see how it really goes. Okay, so I just want you, these two are easy to understand, that what we have we will understand, that what we have not we will come in get this in future. Okay, so in implication, true and true goes true. Why? In implication, like we need p must be true and q, it's just like a condition and a promise, like okay. So should be both must be true. Okay, but here's the thing. Say P always must be true for this implication. Why? Because if P is not happening, then how Q will happen? If P never happens, how will Q happens? Right? Q is like condition is never happen, then how could be result come, right? So P must be true in implication. Okay, so true becomes true. Okay, true, our condition is met, but our promise is false, so it's become false. Okay, now here see, it becomes false, but it's the Q is true, the this is also true. Why? Because the condition is false, but our promise is true, right? So the promise is true, just why this that's why it's become true. But why this false becomes true, right? See, here's what they have formula thing, right? This also makes sense, right? It's not make sense to me, but let me explain to you. So I thought for a second, okay, negative becomes false. That's the thing. But no, I don't want to accept that thing. So I just searched this and got this. So if P then Q, right? Implication implies P then Q, then it evaluates to not P. So what happened with not P? It's become true, and this become this thing, right? But here is a false. So and it have or Q. So we have understand this not. So whatever the true will be, it become false, right? So we have false over here. So false become true, and we have this or thing, which is the same thing or. So one must be true, and we got one true because this is false over here and it's opposite, so it's become true, right? And once we get true, it's become true because or has a property that one of these things have to be true. So that's why I only in implication the one thing is false, which is when the promise is not made but the P is true. So true false become false. The rest of the thing is true. Let's see an example of a solved examples for understanding. Find the truth table. P and Q in the parenthesis implies or implication P. So let's see this. We have this thing which is this, and how we remember is true, false, tutti frutti, like this. I remember it basically. So true, false. This will be same for PQ, and here's the thing. Okay, this is P and Q, right? I have the habit to remember the symbol like this. I made this A, that's why I remember this is and symbol. And symbol is like basically we both must have true, right, in order to get the result true. So we are just doing this thing over this table, nothing more, right? We are just doing this over here. So true become true false become false true become false, and false become false. Why? Because we need both true to happen true. If one of become false, then it automatically becomes false. Now let's see this thing. Okay, P and Q. Now we will ignore this column and compare the result for this, making the result for this. So true, and now we are making this table. Now we are making this implication table, but with the help of and table. And table and implication table. We are combining this table, but we ignoring the Q state. Ignoring the Q column. Okay, P and this right to get the result. So true, we will go by this because this and then this. So this is our now P and this is our Q in implication. So this is our P and this is our Q. Okay, so true, P have true and Q have true. So P have true, Q have true, it's become true. So we got true. True, false become false. Oh, sorry. True, false become true. We have sorry. False. This is P, right? This is P, and this is T. So, false, true become true. That's how truth tables help. So, and false, true becomes true once again, and false become true as we remember with this, and false becomes true. And that's the thing. And once we got this all true in result, it's called true tautology. Tautology. And that's all for this video. I guess I need to learn. Let's learn few more things in next thing. There's already a 20 minute long video. Okay then. Yeah, gotcha.